In figure, AB and CD are two chords of the circle intersecting each other at point O. Not point O, sorry, point E. So this is the point E and these two are your chords. Chord number 1 and chord number 2. Prove that angle AEC, this particular angle, is equal to half the angle subtended by the arc CXA. CXA is over here. That's your CXA, and the angle subtended by arc DYB. So that's your DYB at the center. So with respect to the center. Okay. So as usual, we'll begin our discussion with calling this as, say, 2 theta. So whenever we get such question, we'll call it with some variable. This can be 2x, I guess. Okay. So angle subtended by this arc at the center is 2 theta. Angle subtended by DYB at the center is 2x. Right? Okay. Next question to you guys is, what should I use over here? In general, if you have an angle subtended at the center. Yes, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So we'll be having the following. This would be, this particular angle would be theta, right? Have a look at it, pause and think over. Okay, if this were the chord, say this were the chord, this is the angle subtended at the circumference and this is the angle subtended at the center. Agree? So this realization is must. Similarly, if DYB has an angle of 2x at the center, how much will it end at the circumference? This particular angle? Yes, this will be x. Okay, so this is one common thing that we can conclude, and this information we have to carry it over solving the above question. Right? How will we do that is something that you guys have to pause and think over. Meanwhile, I'll keep writing your answer. So you can keep thinking, pause and think, or you can just think over now. So we have to prove, it's a big proving statement. I'm not going to write the entire thing, that you guys can write. Then proof. Okay, how is that we're going to do this? So we'll start off with calling let angle BOC be equal to 2 theta and angle DOB be equal to 2x. That's the first thing that I will talk about. Next thing is the angle subtended by this arc with the circumference is theta. So we have angle ABC will be equal to angle AOC by 2, which is equal to theta. Then we have angle DCB, which is equal to half the angle of DOB. So this will be equal to x. But why is this? What is the reasoning? The reasoning is that, yes, angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Angle, I think we'll write it in the next line. Angle subtended by an arc at the center is double the angle subtended by it at remaining part of the of the circle. Agree? So now, how can we make use of this is the question. How can we make use of this information? So we have in this particular triangle those set of angles, right? Please have a look. And the angle that we are trying to figure out, for which we are trying to relate all of this, is this. So your next clue is this line. Now think. We are trying to talk about this angle. Yeah, how will we go about doing this? Yes, we have the following thing. In triangle ECB. Yeah, how will we do this? It's quite simple. Yes, exterior angle property, is it not? As per exterior angle property, angle AEC is equal to angle ECB plus angle EBC. Please have a look. So what we have here is a triangle. I'll just draw it big so that you guys understand. So this is theta, this is x, and that's your exterior angle. So that's what I have written. So that is equal to, this particular angle is equal to sum of these two angles, is it not? So this is your exterior angle theorem. Agree? Okay, next what? This is x and y. So all we have to do is, this is equal to x plus y. Not in this case, it's not y. In this case, it is theta. And finally, what do we have? This is nothing but half of 2y plus 2 theta. And this is nothing but half the angle subtended by the arc AXY at the center plus the angle subtended by the arc DYB at the center. Angle subtended by the arc, what arc? AXC at the center plus angle subtended by the arc DYB at the center. Close the bracket. And we have the answer. The writing part, as usual in geometry, is huge, but thinking part is very simple, is it not? All we did was call it with some variable and take the law which I have been using a lot, right? It's very familiar. Most of it we have been using so many times, so you guys have a familiarity by now, hopefully. And on that, we build on all this.